Hey guys, so I'm still in section 3.6. This is part 3. I'm on page 286 here. And now what I want to talk to you guys about is going back to something we've discussed several times. So I want to now solve quadratic equations by graphing. So in this first equation here, so I have x squared plus 5x plus 4 equals negative 2. So I just want to make sure you kind of understand what we're looking at here. This part here, this is the quadratic. So this part here, I'll use the red color. This is actually representing my x squared plus 5x plus 4. And then this part that says equals negative 2, that's what this dotted line is here. So this equals negative 2. So just helping you to kind of interpret these graphs a little bit better. Remember, the strategy that we use for solving equations with graphs is that we graph each side of the equation. Here's one side, and then we graph the other, and then we just look at where these graphs intersect. So where does this line intersect with the dotted line? Now, also keep in mind, one thing that I think sometimes gets confusing for people is they're like, well, how do I know if I need to look at this line and where that graph intersects or the other line? So it depends on the question. In this question, I'm being told to solve this equation. However, so pretend for a second that this line wasn't here. So I'm just putting some yellow over this so that you can forget that the yellow part is here. If I just gave you, and forget that this part is here too. So if I just gave you this part of the equation and I said find the x-intercepts of this, that's where you look on the x-axis and you look for that. But that's not what we're being asked here. In this case, I'm being asked to solve this equation. And so that's why I have these two things graphed here. So it's really dependent on what type of question you're being asked. Now, when I look at this, I see 2 points of intersection right here. What are these points? Let's label them. This one is, well, I don't even really need to know my x, I don't even need to know what the point is, right? I just need to know what is the x coordinate. So if I just look up here on the x-axis, I can see that the x coordinate here is x equals negative 2. And then for this one here, if I come up, this is x equals negative 3. So my solutions are going to be x equals negative 3 and x equals negative 2. But now what I want to do is I just want to check to see if this actually works. So I have x equals negative 3. I'm going to plug it in. And so now let's just work it out. And this will give me really 13 minus 15, so that equals negative 2, so this solution works. So now let's just check the other one. So the other one was x equals negative 2. So if I plug that into the equation, it'll look like this. And if I solve this, I get 4 minus 10 plus 4, so that definitely also equals negative 2. So these two solutions I found just by using the graph. So we're just going to kind of review how you can use the graph to help you find solutions for right now. So what I want you to do is look at the graph here for B and find the solution for this one. So it's between the parabola and the dotted line. What is that solution? Pause the video, find the solution, check it, hit play when you're ready. So in this case, my solution happens right here. So this is at x equals negative 1. So let's check it. So this will give me, so if I check this, so I want to plug this into this equation here. So this is negative 1 squared plus 3 times negative 1 plus 3 equals negative 1 plus 2. So now I just got to work this out. So this is 1 minus 3 plus 3 equals 1. And this will give me 1 equals 1. So in this case, I found the one solution. So this is also an interesting thing to note here. This graph only had one solution, while this one had two. And that's totally possible. So quadratics can have whatever amount of, they can have more solutions than a linear equation. So this is part of what makes them a little bit different. Okay, so now that we've looked at how to solve equations, now I want to go back to that part I was just talking about with x-intercepts. So just to remind you, how do we find x-intercepts? How does this relate to where x-intercepts are on the graph? So to find x-intercepts, we can basically say that it's where the graph intersects the x-axis. And remember, x-intercepts have the form, you put something here for the question mark, but the y-coordinate is always 0. So now that we know how we find x-intercepts, how do you think that we find y-intercepts on a graph? What would we actually look for? Well, you'd look for where a graph crosses the y-axis, and these have the form 0, comma something. So we fill in whatever for the question mark, but this is kind of the general form. So now we're kind of pivoting. So now I'm not asking you to solve equations. Now I'm asking you to find x-intercepts. So let's do it together. On this graph, so first things first, you can see the y-axis and you can see the x-axis, and maybe I'll just kind of label these as a reminder in case you're getting thrown off with directions. So looking at this, where are the x-intercepts first? Circle them and then write out what the point is. Okay, so I have 1 point here and 1 point here. So my x-intercepts, I have 2 of them. They are the points -1, 0 and 1, 0. Now I want you to locate where the y-intercept is. Go ahead and locate that and write it down. So the y-intercept is right here. Now be careful with this. The y-intercept, the form of this point, is 0, 1. So this is what makes x-intercepts what they are versus what y-intercepts are. Now, the last question, so the first part of this was just to identify those, so we're familiar with that. Now, the second part of this asks us to describe what equation we can solve as a result of this graph. So, the equation that we can solve, we actually can set this up in 2 ways now. So we're kind of adding on to how we view points and the power of relating functions, points, and equations. So let's just start. I'll use this orange color here. So let's just start with what equation can I actually solve here? Well, what this tells me is that if I were to set my equation equal to 0, I would know the 2 solutions. So I'm going to write that down in that, so let's say I have -x² + 1, and I set that equal to 0. Now I know the 2 solutions to this. The 2 solutions are just the x-coordinate. So my solutions are x equals -1 and x equals 1. That's what the points are telling me. Okay, so now let's interpret this for the y-intercept. So I'm going to add on something a little bit different here. The y-intercept, so before this was setting an equation equal to 0. Now what do you think I can set my equation equal to? Well, you always set your equation equal to whatever the y-coordinate is. So in this case, I will set this equation equal to 1. And what would the solutions to this be? The solutions, again, are found in the point. So I've set my equation equal to 1, and my solution is still the x part of this coordinate. So here is this. So you get a lot of information out of kind of understanding your points. In this case, I took my x-intercepts. I said that I can set this equation equal to 0, and if I just look at the x-coordinates, I will get to the solutions. Then for the y-intercept, so here it is here, I located what the point is, and now I said, well, if I set this equation equal to the y-coordinate, so the 1, I still know what the solution is. It's just this x equals 0. So this is just, again, we're adding on to something that we've noticed, and it's a very powerful concept. So I want to just go through the last 2 pages because I think that they actually build off of this pretty nicely. So let's do another example of this. So what I want you to do, let's start with just the x-intercepts and what equation can be solved. So I want you to find the x-intercepts of this graph, write down those points, and then write down what equation can be solved as a result of that. Hit play when you're ready. So my x-intercepts in this case are here. So what are these points? These are the points, let's see, I gotta be careful. This is -1, 0 and -3, 0. Those are the 2 points. Now that we're here, what equation can I actually solve? Well, I can take this and set it equal to 0. So that 0 comes from the y part of the coordinate. So I'm going to set this equal to 0. And then what would the solutions to this be? The solutions to this come from the x part of the coordinate. So the solutions are x equals -1 and x equals -3. Okay, so that was for the x-intercepts. So now I want to pivot to the y-intercept. So there's only one y-intercept here. So I want you to do the same thing. Write down what the y-intercept is and then write down what equation you can solve as a result of this. Hit play when you're ready. Okay, so as I'm following along this graph, so here's my y-axis. So here's where my y-intercept is. So my y-intercept is the point 0, 3. So the equation I can solve from this is taking this and setting it equal to the y coordinate. So one way I can kind of interpret this is I can set my equation equal to 3, and then I can say that a solution to this would be x equals 0. Now, I'm going to throw in one other plot twist with this, so hopefully just stick with me here for a second. So in this equation, I have actually two solutions. This is something a little bit different. Do you think you can figure out how I would get to the second solution just by looking at the graph? I'll give you a big hint. Here's my line where all things equal 3. Anything here will equal 3. Can you see where a second solution might arise? Well, a second solution would arise right here, right? This would be another point where this intersects. So this is a y-intercept because it's what intersects the y-axis, but this is not the only solution. There's actually a second solution in this case. It's here at, let's see, what is this point? This is the point -4, -3. So the second solution is x equals -4. And you could plug these in to check these. So now you might be thinking, well, how is that different from the last one? Why wasn't there two solutions to this one? So going back to this graph, so I just want to look at this one more time. There's something unique about this y-intercept. So look what happens when I draw a line all the way across here. How many points on this graph actually intersect this line? It's just this one here, right? So in this situation, there is only one solution. And there is only the one y-intercept. In this situation, this is the one y-intercept, but it turns out there are two solutions. So this is a little bit of a subtle thing. But for now, the big thing that you really have to be able to do in this section is find just your x and y intercepts. That's the biggest part of this. This other part here is a bonus, so if you're struggling with this a little bit, don't lose too much sleep over it. Okay, so we're almost done. I know this video is a little bit longer, but I want to just get this done with since there's not much left. So, example 10. Now I want to add in a new piece of information off of the exercise we just did. A ball is thrown upwards from a cliff that is 30 feet above the ground. Sounds familiar. This situation could be modeled by this quadratic equation. So this is the same quadratic we just saw a couple pages ago, right? Now, h represents the height of the ball thrown after t seconds. How can we determine when the ball is 42 feet above the ground? So all I want to do now is say, do I have enough information to actually figure this out? How could I figure out when the ball is 42 feet above the ground? I've got this equation. What do I have to do to this? Well, all I have to do is leverage this 42 feet. If h of t represents the height of the ball, then this 40, and I want to know when is it 42 feet, I just need to set this equal to 42. So I set this equal to this, and then I need to solve this equation. Now, where we are right now, we don't have a way to solve this equation just as it is. So instead what I want to do is I want to try to solve this from a graphical standpoint using what we've already kind of talked about. So this brings us to the very last example, and then you're all done with this lesson. So notice what I've done here. We set up this equation. So we set this negative 32t squared plus 64t plus 30, we set it equal to 42. So what I've done is I've gone through and I've actually graphed both sides of this. So here's what this looks like. This is like a not nice looking graph because we're using more real world data, right? So real world data is not going to always look as nice. But you can see this red graph here. This is still a parabola, right? It's just super, super tall. And then this dotted line represents my 42 feet. So now what I want to do is blow this little section up. So I'm going to go in here and go in wide, and that's what this piece is here. So what I've done here is I've just totally blown this up as much as possible. So I want to estimate, here's the red line and here's the little dotted black line. What would be the solution to this equation since I can see this now? Well, my solutions are here and here. So I have to estimate them. So if you come down, you'll see that you can make like a estimate. So down here is like where the x-axis is. So you have to just make kind of a little bit of a guess here. So I would say this is maybe somewhere around, x equals maybe something like 0.19. And then here, if I come down all the way down and I try to count, so it's 1.5, 1.6, 1.7, the 1.8. So we'll say this is maybe somewhere around 1.8. So here would be my two solutions in this case by just using that method where we just read it off the graph. And so what does this actually mean then? This means that these are talking about time, right? So the ball achieves a height of 42 feet at 0.19 seconds and 1.8 seconds. And if you look at this, this makes sense, right? So you're throwing the ball up, you throw it up pretty high, and then it comes back down. So in the trajectory of this, it goes up, it goes down. Here's where it hits 42 feet at two different points in its trajectory. Okay, so that will wrap up this lesson. So great job, guys. Thanks for watching. I'll see you next time.